Problem given in waves and oscillations. So in a string in a musical instrument is given 50 centimeter long and its fundamental frequency is given 800 Hz. So if a frequency of the second wire, so after oscillating 1000 Hz you are getting is to be produced here. So then the required length of the string is what? So according to the condition, the frequency of the string we know. So what is the fundamental frequency of the string? F is equal to 1 by 2L into root T by mu. So in this formula, so this T represents the tension produced in the string and mu represents the linear density of the strings here. So in both the cases, the two wires having the same linear density, so automatically both are having the tension is also same. So that's why the root of T by mu is constant. What is the relation now we have to get here? So F is inversely proportional to length. So now I am comparing the two equations, two strings. So in that the frequency of the first string I am considering F1, frequency of the second string consider F2. So according to that I am getting the relation L2 by L1 here. So in this L1 value is also mentioned, F1 value and F2 value is also mentioned. F1 is the string, it has a musical instrument, its length is equal to 50 cm. At that time, the frequency, fundamental frequency of that string is 800 Hz. So that's why here F1 is equal to 800 Hz. And next second one is frequency mentioned, that is 1000 Hz, that is equal to L2 value we don't know. So L1 value is mentioned 50 centimeters here. So from this relation L2 we are getting, so 0 is cancelled. So this side is also cancelled or taken to this side. Then you have to get L2 is equal to 40 centimeters. So now 40 centimeter at this length, the second one having the fundamental frequency is equal to 1000 Hz.